Hi guys. Okay, so today we're going to look at the probability of multiple events. So doing one thing and then having something else happen. And there are two types of things that can happen. We can have events that are independent and events that are dependent. So we're going to talk about those. Independent events are when the result of the second event is not affected by the result of the first event. The probability of one does not change the probability of the other. So if I roll a die and I want the probability of getting a 2 out of 6, then I'm going to take the die and I'm going to roll again and the probability of getting a 3 out of 6. Those don't affect each other. Each time the probability is 1/6. It's not changing. So when we have independent events, the probability of both events occurring is the product of the individual events. So remember, the probability of A and B, that's the probability of A intersection, that's what they have in common, B, is the probability of A times the probability of B. This is sometimes called the probability multiplication rule because we multiply. Okay, so let's look at an example. So a drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and then replaced. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and the second paper clip is blue? All right, so the first thing I want to know is what's my sample size? Okay, first thing is what's the sample size? We have 3 red plus 4 green plus 5 blue. 3 plus 4 is 7 plus 5. We have a total of 12 paper clips. Okay, because that's our total possible. That's going to be the denominator in each of our probabilities. So now we want the probability of getting a red, and so we multiply the probability of getting a blue paper clip on the second time. So the first time in, when we reach into the drawer, there are 3 red paper clips out of the 12 paper clips altogether. Now we're going to put that red paper clip back in. Now when we reach in, there are 5 blue paper clips out of the 12 paper clips. Okay, so if we go ahead and we do some multiplication, 3 times 5 is 15, over 12 times 12 is 144, and we're going to simplify that to 5 over 48. Now here's the thing about the simplifying, guys. Sometimes in multiple choice, you might see the answer as 15 over 144. Sometimes you might see the answer here, so you need to realize that the answers are equivalent. If it's one of the long problems where it's not multiple choice, I want you to simplify your answer to lowest terms. We want you to reduce your answer. So 5 over 48 would be the correct answer. But if you're doing multiple choice and you get, because you type in your calculator 3 12s times 5 12s, it's going to bring you right to that final answer, 5 over 48. Okay? If you don't see that, go back and look at the choices before you decide you did something wrong and see if any of the choices reduce to 5 over 48. Okay, so if 15 over 144 is one of the choices and you type it in your calculator and hit enter, it's going to reduce to 5 over 48. That's the catch with multiple choice questions on probability, is you don't know whether or not they're going to reduce each time. Sometimes they might, sometimes they may not. Okay, so that's the problem that you might find with multiple choice questions. One of the reasons I don't like multiple choice questions. Okay, so now let's talk about dependent events. So in dependent events, the result of one event is affected by the result of another event. Those are dependent events. If A and B are dependent events, the probability of both events occurring is the probability of the first event and the probability of the second event once the first event has already occurred, okay, because it's going to change. So if A and B are dependent events and A occurs first, the probability of A and B is the probability of A times, whoa, what is that? The probability of B, and then there's this up and down line, A. This is the probability of B such that, that up and down line is a mathematical symbol for such that A has already happened. Sometimes in math you'll hear a professor say the probability of B given A. That's not quite as clear to me. It's the probability of B such that A has already happened. Okay? Now, another term you might hear is that when you're dealing with dependent events, you're dealing with conditional probability, because that probability of the second event is based on the condition that the first one already happened. That's why it's conditional probability. Now, let's go back to our paperclip problem. Okay, so a drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and is not replaced this time. So this is the part of the problem I've changed. Another paper clip is taken from the drawer, and what is the probability that the first paper clip is red and the second paper clip is blue? So our sample space is still 12. We still have the same number of paper clips. But let's take a look. We want the probability of getting a red paper clip times the probability of getting a blue paper clip, given that we already pulled out a red paper clip. Okay, so when we reach into the drawer the first time, there are 3 red paper clips out of 12 paper clips in the drawer. Now, we're going to keep that red paper clip. So now when we go back in that drawer to get the blue paper clip, there are 5 blue paper clips out of, now be careful here, there's only 11 paper clips in the drawer. Okay, and that's the key. Because it was not replaced, the sample size changed for the second event. And that's how its probability was affected by the first one happening. Okay? Because the red already happened and is no longer in the drawer, there aren't 12 paper clips anymore. So now we're going to go ahead and we're going to multiply. 3 times 5 is 15 over 12 times 11 is 132, which if that's a multiple choice answer, you're done. But we can reduce that to 5 out of 44. And this would be our final answer. The probability of getting a red, not replacing it, and then getting a blue would be 5 out of 44. Awesome. Let's look at another one. Okay, this problem looks very much like what we were just doing. It's the same 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and is not replaced. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and the second paper clip is also red? So this time we want the probability of getting a red, and so we multiply the probability of getting a red paper clip, given that we already got a red paper clip. So when we reach into the drawer the first time, there are 3 red paper clips out of the 12 paper clips in the drawer. Now I've got that paper clip holding my papers together. So now there's only 11 paper clips in the drawer. And not only that, because I took one of those out, there's only 2 reds left in the drawer. So now not only did the sample size change, but the numerator also changed. And when we multiply, 3 times 2 is 6. 12 times 11 is 132, and this will reduce to 1 over 22 as our probability. Awesome. So now the thing to watch out for, guys, when you're doing independent and dependent is look for those words replacement or returned. With replacement, the events are independent and the probabilities do not affect one another. So it's just the probability of the first times the probability of the second. Without replacement, the events are dependent. The second probability is affected. The sample size, at least the sample size will change, if not something else, okay? So look for the with replacement, deep independent events, and without replacement, it's dependent. That second probability is going to change. All right, guys, have a wonderful day. Bye.